Eastman. He's here to talk to you guys about his mechanical engineering career. So let's give him a round of applause.
How are you guys doing today? Good. Good, good. So I've got a real connection to BSE. My son attended camp here. I don't remember if it was 1 or 2 years, but it was a great experience. And I think I still have and recognize some of the apparatus that you guys are working on, so I know exactly what you're doing. I know the program, it's very exciting, and you guys enjoying it?
Yeah.
Great, great. And also my son and daughter went to this school. So not only are you in a great engineering camp, you're also in a really storied, wonderful academic institution. So congrats, and I hope you're enjoying it this year. So BSE reached out, and they wanted to, have me speak and sort of let you know, or have me let you know where my career has gone. Gee whiz, I graduated as a mechanical engineer from UMass. We'll go over the, some of the specifics, but I'm out of school since 1983. So gee whiz, we're talking about 32 years of industrial experience, and I've had, fortunately, some really interesting jobs, interesting places to go. I'll go through it. A lot of this is pictorial and stories. So if you have any questions, by all means, let me know. Stop me. Raise your hand. And we have till what time? About 1 o'clock.
Sure. Take as much time as you need.
Terrific. Oh well. If I would be here till 6, and we have a couple of people falling asleep. So okay. I started out of school. I worked for a company called General Signal, a little firm out on Long Island. And I have to tell you a funny story, then I'll move on. But I was asked, as a mechanical engineer, all the theory in my head and all that. And so they asked me to strengthen one little part. Now here I was coming out of school, and I had all the theory in my head. I had automatic control systems, thermodynamics, 5 semesters of calculus, fluid mechanics, and all that. And honestly, I had no clue how to do this little project that they gave me. So, what you're doing here, frankly, is I wish I had done that, because that really grounds you in materials and construction techniques and all that, and even design. So kudos to you guys. I learned quickly, because I was there for about 2 years, had a great career. I was designing things for the Taiwanese Navy, as a matter of fact, and some other air traffic control systems. By the way, if you've ever seen, it looks like a white flying saucer in airports. It rotates. Have you ever seen that at airports, at the top of the towers? That's called an airport service detection equipment, and that actually came out of a little company, General Signal, called Cardion Electronics. And I worked a little bit on it, but I can't claim too much fame to what I did on it as a junior mechanical engineer there. Moved on to a company called United Technologies. Who's heard of United Technologies? I can see. Okay, here we got one person. Well, UTC, Carrier Air Conditioning, Otis Elevator, Pratt Whitney jet engines. Who's heard of Sikorsky helicopter? Anybody heard of Sikorsky helicopter? There you go. And when I was there back in 1985, they had another division called Norden Systems. Anybody ever hear of Norden Systems? All right, another storied old, and some of these companies go back so far that they're not even around anymore. They've been bought up by other companies. Well, Norden made an interesting thing called the Norden bomb sight, and that was a storied company. I also did more designing of aircraft radar, or radar used in aircraft. And some of my stuff was in what's called a J-Stars, with a 707 with a radar in the belly. Really neat stuff. Moved on to a company called Dell Global Technologies, and this was probably, as a mechanical engineer, one of my most interesting jobs as an engineer. I was designing high voltage power supplies for industrial and scientific equipment. High voltage is really, if you're an electrical or mechanical engineer, it's a fascinating field. I did things in oil exploration equipment, scientific research, medical imaging, and medical blood analysis, things like that. So fantastic field, and I really used a lot of my engineering skills in that firm there. Moved on to a firm called Siska Hennessy Group, an older engineering management and consulting firm located here in New York City. They did designs on Lincoln Center, the United Nations, Presbyterian Hospital up on 168th Street and here on 68th Street. So again, fine firm, and there I actually led their building commissioning group, and we'll talk a little bit about that in a minute. 3 years ago I joined Jacobs Engineering. Anybody ever heard of Jacobs? Jacobs has, okay, great, thank you, Sandy. Jacobs has about 70,000 people worldwide, a lot of servicing for the oil and gas industry. And we also have a buildings design division, and my group does building commissioning in New York and the surrounding areas. So we'll talk more about that stuff in a bit. So, so here's the positions that I've held during my career. Started out as a mechanical engineer, moved to a senior mechanical engineer, was a chief mechanical engineer. Got my MBA, we'll talk a bit about that in a moment, then was moved to an operations manager to manage manufacturing. Then I was the vice president of operations at a division in Hicksville, Long Island, became president of that division. That was really interesting and a lot of fun to do. Moved on to Susquehanna, became a senior vice president, director, and then I was also an associate professor at Pratt Institute. Oh, sorry.
Is Pratt Institute connected to the paper mill by any chance?
I don't believe so. I don't believe so. Pratt Institute is it's an old, it's been around for many years, a university in New York City, Brooklyn, and Manhattan. So great question, but I don't believe it's associated with a paper mill. So senior vice president, director. So you know what? With all due respect, titles are great, but it's not what they call you; it's what they pay you. So trust me when I tell you, the titles may be different, but the pay always went up, except for the professor at Pratt Institute, where I think it used to cost me more to park my car on 14th Street than what I was getting paid there. But I enjoyed doing it. I enjoyed every minute of it. So my education, did my Bachelor of Science in Mechanical Engineering at UMass in a little town in northwestern Massachusetts called Lowell, Massachusetts. It's a real culture shock from somebody being from New York, but it was a really wonderful experience, and I'll tell you, my mechanical engineering education has been superb. It's served me for the past 30-something years. Really enjoyed it. Decided long ago, even before I started the MBA program, that I wanted to be involved in business. So I got an MBA in corporate finance. So really what that let me do, well, I kind of joke around and I became half an accountant, in addition to being an engineer. But the MBA let me take on the business side. So really, I manage people, I manage businesses, I figure pricing out. I understand why we do things in the engineering field and how we calculate, basically how we stay in business. And that's what I've been concentrating on for, with almost the past 20 some odd years, is engineering management and the finance under it. So it's given me a lot of opportunity to do some very interesting things. Became a certified facility manager. It helped me in some projects I used to work on, and now certified commissioning authority. And that's helping me out with that, what I'm doing now in building commissioning. So I got to tell you, I've had some really, really great trips as an engineer, and I've probably logged well over 2 million air miles, about 1.2, 1.3 million just on American Airlines alone, and scattered. So I really lost count. That might be conservative. I've been to some great places. Anybody ever hear of the Azores? Okay, interesting. Neither did I. So, basically, if you're hiding out from the mafia, you may want to go to the Azores. Very few people have ever really been there. It's actually about 800 miles off the Portuguese coast, and the U.S. Air Force and the Portuguese Air Force have a joint base out there. I've never seen a shorter, scarier runway in my life going into the Azores. But I have to tell you, it's one of the most beautiful, friendliest places on the face of the earth. The ocean's really deep blue. I was in Sicily, Italy, at a U.S. Naval Air Base there called Sigonella near Catania, helping them with some software and understanding how to categorize and track all the equipment on the base, the air conditioning systems, the electrical systems, whatever the base needed to understand how their buildings work. Another very interesting project, I worked on a huge project in Egypt for about 3 years. I was in and out of Egypt about half a dozen times in an Egyptian Air Force base called Fayed Air Base. It's really not too far from the Sinai Peninsula. And what we did, we basically trained the Egyptian Air Force how to operate and maintain their Air Force base. Fascinating job. Got to ride a camel, and I loved sending the picture of me on a camel to my boss. I was with Susquehanna then. It was really a lot of fun. So hey, guess what I did while I was away on business? So that was really cool. And the camel was taking me around the pyramids. But fantastic experience. Couldn't think of a more fun thing to have done. Taiwan, I went to a major internet firm to do work there. I can't really tell you what it was. It's confidential, but these are the kind of places that you wind up. And yes, I was at the Virgin Islands doing work for the Air National Guard and Puerto Rico General Service Administration. And trust me when I tell you, I try to arrange these trips when it was really cold up here. So occasionally you get lucky, and there are some perks to some of the engineering jobs that you're working on. It doesn't include tons of trips around the United States, and being born and bred in New York, I had never been to Omaha, Nebraska, Boise, Idaho, or Valdosta, Georgia, or Goldsboro, North Carolina, rural parts of Florida. Wow, I mean, I really, as an engineering, being in the engineering business, I really got to see a lot of places in the world I never imagined I would. So you never know when you're looking for an engineering career where you might wind up. Okay, so that's the travel and leisure plan portion of the speech. I thought that would interest you folks. All right, so I recently completed, we're at the tail end, we're almost done, got a couple more hours of work to do. The Social Security Administration just built a new data center in Urbana, Maryland. We'll talk about that project. And it's something that I'm really proud of. Probably the biggest construction site in New York City, one of the most complicated jobs that you will ever see, and you can all go down and visit the site. It's just a subway ride away. I'm working for the Port Authority of New York, New Jersey. We're contracted for the Port Authority we're actually commissioning the World Trade Center Transportation Hub. Do you folks know what that's all about? Any idea what's going on there? Well, they're reconstructing the path stations, and they're doing, this is the Santiago Calabatra's new transportation center, the transportation hall underneath. Fantastic. Go down there, visit the memorial pools. This will be open in about a year or so. It is, I'll show you some snapshots from inside of it. It is just spectacular. Wait till you guys get to see it. It is really going to be an iconic, it's going to rival Grand Central Station, and forget about Penn Station. You'll just be embarrassed at Penn Station when you see what this is all about. It's really beautiful. And my group, what we're doing is, I'll tell you more details in a moment, but what we're doing is we're helping the Port Authority test all the systems, and so it's going to be open and safe for the public, and it works properly. So we'll go through the SSA data center, but I'll give you folks a little bit of clue as to what you might expect to do as an engineer out in industry. So you folks know what the ARRA was, the American Recovery and something Act. It was, Barack Obama started it in 2009. It was really a bunch of shovel-ready projects that they wanted to start within the United States. So this data center was one of it, located in central Maryland. Another place I got to visit that I've never been before, Urbana. It's forgettable, but certainly a nice place to go. And basically, the Social Security Administration crunches an incredible amount of data, day in, day out, to take care of Social Security, the Social Security requirements. So, do you folks know what a data center is? Anybody ever hear what a data center is? Okay, give me an idea what you think it is.
Well, isn't it just, I know Google has like huge data farms where
Sure
it's
do.
it's so much data stored in spaces.
Exactly. Well, very. A data center, wherever there, server farms, mainframes, data storage, all that. So the thing that data centers have in common is that all the machines, they crunch data, so you got to get the data in and out of the facility, but they also produce a tremendous amount of heat. And anybody that's got a data center, the thing is they want to be incredibly redundant. So in other words, if something goes wrong with it, hey, it's not like somebody just pulled out the cord of your TV or your computer crashed. They can't have that. Like all the financial firms, this stuff's got to work. So there's a whole science with the data center folks of redundancy and making sure that you've got backup systems and how data centers work. And the biggest thing with data centers basically is cooling. So you've got power. In this particular design, power comes from above, data comes from above, and cooling air comes from the sides. So tremendous science behind this. There's professionals in the data center industry. That's all they do is design data centers, and they're specific, highly secured facilities. So let me just back up 1 second. It's really hard to get a feel from just one photograph as to how big this data center floor is. It's bigger, it's longer and wider than a football field. It's the absolute biggest data center that I've ever worked on. It was just a fascinating job. And just to give you an idea as to scale, I think I'm standing not quite at the back of it, but these images right here, these are men. These are like 6 foot tall men. These racks are about 7, 8 foot tall. And so look how far they are from where you are. It is just almost an unimaginable size. So I'll go through a couple of facts and figures about it. But here was a test we did. So how do you test the cooling system if there's no servers in there? How do you know that the cooling system works properly? Well, you have what these called load banks. And the load banks produce, this one load bank produces 1,000 kilowatts of heat. I'm sorry, 100 kilowatts of heat. So that's 100 hair dryers. So you're all familiar with your 1 kilowatt hair dryer you might use in your bathroom? I haven't used one in years. But at any rate, I'm very funny. But that's 100 of them all in one box. All right, 100 hair dryers worth of heat. And basically that's how we had how many? We had about 60 of them on the floor producing 6 megawatts of heat on the floor. It was really fascinating to simulate the heat. In a data center, you don't put water on the fire. Why don't you put water on a data center fire? Any clue? What's that? Yeah, you'll ruin the servers. It's a lot of electrical equipment, and you'll ruin the servers. So you don't want to put some. What this is called clean agent, and the clean agent. But there's a bunch of techniques of how to extinguish a fire in the data center. This one here, this actually lowers the temperature of combustion so that combustion can't be supported. But there's other fire protection systems that actually smother the fire. Smothering is not that safe, because if somebody in the room and you put out too much of that gas, you actually you can suffocate folks. So you don't want to smother. So special fire suppression chemical, no water, drops temperature so combustion is not supported. And you don't want this to go off by accident. It'll cost roughly $250,000. It's really embarrassing to tell your boss that the clean agent system discharged when it didn't have to, and you have to fill up the tanks again. By the way, that data center had 10 of those rooms with those bottles in there, so it was a major part of the system. Okay, so this was the chiller plant for the it's really hard to get a view of the scale here, but there are 4 big chillers, and one chiller would actually occupy almost the size of this room. The four chillers, these are the air conditioning systems, together could have enough air conditioning capacity to air condition 4,000 average homes. Think of that. In this one room, we had enough chilled water capacity to air condition 4,000 homes. It was really, really huge. In this data center, too, a couple of other facts and figures. We had a 1 megawatt PV array. Who knows what a PV array is? Ever hear of photovoltaic? Okay. We had a 1 megawatt photovoltaic array, and in actuality, when the sun was shining, because they didn't migrate much of the computer center in there, didn't much servers while construction was just finished, the PV array was almost carrying the entire data center. That was lighting, air conditioning, whatever IT load that we had. The PV array was almost doing the entire thing. And the electrical system, we won't go too much into that, but we had enough electrical capacity to energize 3,000 average homes in this one facility. So needless to say, there was a lot going through there, and Uncle Sam spent quite a bit of money making this work. So just a couple of interesting things that I thought were just incredible. So there were sensors located throughout the data center floor. That what's called the heat map, so it shows where the heat is and how to protect the servers. So for example, the redder it gets, the warmer it was, and this was during one of the heat load tests that we did. So we knew where the the heat was located, and a lot of that was based on, and there was no fan over here, so we expected a little bit higher temperatures. Worked really well. So that's what some of the trends are nowadays. And then it used to be they never had like process control systems like this before, so you could actually tell what machine is operating and actually operate this you operate the whole thing from a laptop computer. the entire data center just from a laptop. You don't have to turn a valve, you don't have to pull a switch, you operate the entire thing through a laptop. And it tells you everything that's going on, from flow rates to what's on, what's not operative. So that's the story about the SSA data center. Very recent project. I was there for the last time in May doing a warranty review. Very, very successful. And I have to say, one of the most successful government programs that I've ever worked on. It worked, and believe it or not, it was on time. So it was the government, they actually did a great job. Yes?
Just one quick question about the how to put out the fires.
Sure.
How exactly does the system lower the heat of combustion?
It's a chemical reaction, and I believe what happens is when it senses combustion, it's a you ever hear of it's endothermic. So it creates an endothermic reaction, which is cooling. Endothermic is cooling, and it goes ahead and I don't know much about the chemistry, but in essence, from a thermodynamic standpoint, the clean agent contacts the heat from combustion, and it creates an endothermic reaction, which is a cooling reaction on it. I hope that helps.
Okay.
Okay. Okay. Any other questions? Great. So the other project that I thought would interest you folks is the World Trade Center Transportation Hub. I've been working on this project since 2012 when I joined Jacobs, and probably got another 1.5 to 2 years to go until it's really complete and almost fully handed off to the public. So most of what we're doing is below ground, except for the Santiago Calatrava's Oculus that you've seen a bunch of pictures of. I have a couple of pictures of it here. Construction, we're keeping track of 1,500 pieces of equipment and roughly almost 3,000 testing processes that we're doing there. It's incredibly complicated. Trust me when I tell you, we need a computer to keep track of what's happening. The construction's done in phases, it's turned over to the public in phases, and we have to test it in phases. So it's really, it's a project with a lot of logistics. All right, so here I am. I'm at the top of One World Trade, and I'm looking down, and there's the Oculus from 110 stories up. Kind of cool. It's got operable skylights. They open up. We're going to test them shortly in the next couple of months to make sure they don't leak water. The design is by what they call a Black Cape architect, Santiago Calatrava. He's produced iconic and very interesting buildings all over the world. So we're testing for water tightness, we're testing for fire protection, that it's ventilated properly, that the air conditioning, the lighting systems work properly. All of these are critical to building codes to make sure that it's safe for the public to walk in. Every building that you're allowed to go in needs a certificate of occupancy, and somebody from the city or the authority of local jurisdiction have to make sure that the fire protection is correct and effective. They make sure also that that when the lights go out, that people can get out of the building. So this is all the stuff that we help the Port Authority test. Any questions? Okay, so this is on the inside. This is actually the mezzanine, I believe, to platform A, to the PATH train. Anybody taking the PATH from World Trade?
No, but I know it.
Oh, you know it? Okay.
Yeah.
Yeah. This is the PATH from World Trade. I think it goes to Journal Square. Is the next station. So you could actually go through this right now. Just pay your your PATH fare, and you can walk into this right now. It's open to the public. It's up and running. So this is the mezzanine. The tracks are below. I'll have a picture of the tracks in a minute. There's elevators for the handicapped access, and believe it or not, a tremendous amount of engineering work to go in to make sure that those elevators work, and that they work. They don't trap people during fires, and then if there's a power failure, that the elevators are able to go to the proper level of egress. So we're testing all of that. And all these elevators have fire protection in them, and they have pumps in case they flood. And so all the elevators are a tremendous amount of work. Emergency lighting, not too many windows in this facility, so if there's a power failure and the lights are de-energized, how do people see to get the heck out of there? So that's what we test. We also test that. Fire alarm system for the World Trade Center. I actually commissioned a consultant to help us understand how the fire alarm system worked. It was incredibly complicated. Keep in mind, you're monitoring smoke, you're monitoring heat, you're monitoring pull stations, you're monitoring elevators, escalators, heat detectors in all of these places, and it all is kind of on a big electronic ring. So it was too complicated for me. I had somebody figured it out for me. Public address system and radio communication. Why is radio communication important? You guys, you might be a little bit too. Go ahead.
There's no cellular connection.
Too. And I have to tell you that during 9/11, when the cops and firemen were trying to radio each other, they found that their radios were incredibly ineffective in communicating to the site. So right now we're helping the Port Authority commission and get working this huge radio and telecommunication system so they can communicate with each other. So another very important facet of what we're doing. Here's the train platform. Again, a lot of the systems, UPS stands for uninterruptible power storage. All right, so in other words, a lot of the critical systems are operational. Lighting, public address, signage. So there's the platform. And by the way, that marble's from Italy. It is absolutely beautiful. It's Italian marble lining the entire floor and walls of the station, and you'll see that throughout the transportation center. So, geez, I'm sorry guys, it's a really cruddy picture. This is a picture of inside the Oculus. I'm actually standing inside the transportation hall, and here they're erecting the sides of the Oculus as it's coming up at various stages. This was probably taken about a year and a half ago. And here's another picture. This is from an inside, much more recent picture. And you can see all the ribs are up from the inside where the glass is going to go in between all this stuff. And you've got these platforms up there, temporary platforms. That's where some of my guys are going to be standing. They won't let me up there. I guess they're probably smart. But my guys will be standing there testing the smoke heat detectors, the ventilation fans, the lighting. Anything that's up there has got to be tested from the platform. So very, very interesting. And it's thankfully, I'm not doing a whole lot of traveling now, but this is at least an interesting place to go almost every day. And this is some of the pedestrian corridors, and you can go through. This is the east-west corridor. This goes from, you guys know, the World Financial Center, Brookfield Properties, I guess you know, and it goes through to the what's called the NTA, North Temporary Access right now, to get into the PATH station. You guys can walk through this, so if you're going to go see the memorial, go through this. There was a lot of engineering work to get this to go, because you've got to have proper ventilation rates, and again, emergency lighting, communication, access, and there's a fire door system that actually has to close properly in case of certain signals. So we got all that working, and now it's open to the public. So I thought I'd talk a little bit about today's trends. So that's some of the projects that I'm working on. So I'll give you a few minutes of today's trends, and then I don't know whether you're going to eat lunch and get to your projects. So what I'm finding nowadays is that it's called BIM, stands for Building Information System, 3D modeling of systems. They actually are making, there's software packages right now based in, it used to be computer automated design, and I've actually worked on a CAD system for years. I've never had to do really 3D drawings, but now the drawings are intelligent. There's size to them. You could do things like clash detection. So does the plumbing interfere with the electrical conduits, and does that interfere with maybe some storm drains or an air duct that I want to put through? And basically, when you create this whole drawing, you actually create an equipment database. So all these pumps have attributes assigned to them, and we know what these pumps are. So when it's time to do maintenance, we have the entire list of equipment ready for folks. So when you see BIM, that's really the future, and everybody's moving towards that nowadays. Sustainability, you folks know about sustainability? Who's heard? Have you heard the term sustainability?
Yes.
Okay, great. Well, you know, it's the planet's becoming more populated. Sustainability is very important. So there's an organization for the U.S. GBC, U.S. Green Building Council, Leadership in Energy and Environmental Design, Green Buildings, Net Zero Energy. Any questions? Great, okay. Sure.
Do you have a favorite project that you worked on?
I'd have to say that probably not any one project. I mean, the World Trade Center is absolutely the most high-profile project. So I'd say from a project standpoint, that was. But I think probably my favorite job was probably when I was running the division's president of a firm on Long Island, about 120 people there, and basically I integrated engineering, manufacturing, sales, accounting. So I think that was the most, probably the most favorite job that I've had was running a small company, but it was so engineering related. I mean, we were producing equipment for semiconductor manufacturers, healthcare, medical imaging. It was so socially relevant too. So I think it was more of a favorite job that I had, and then I got recruited out of there. Did some other things. So, yes.
Do you still like actively like engineer anything, or is mainly the business and management aspect?
Great question. I have to tell you that it's amazing how much I still use for my engineering day in, day out. I run tests. I stay as close. I mean, my main thing I do now is manage people, manage the business. But I also sell our projects and our services to end users. So I'm the guy that's got to sell the work. I can't sell the work unless I know what's going on. So I stay relevant in testing. I'm there with my hard hat and my work boots, and I go to the site and see that what testing is working, and I do calculations myself, and I help solve problems. So yes, I do. And my engineering background is the foundation of what I do day in, day out. If I wasn't a mechanical engineer, I absolutely could not be doing what I'm doing now. That much I can tell you. So great question. And yes, now I'm not the guy. I'm not going to do drawings. But guess what? My guys come into me, and my guys and gals, by the way, I have to say, there's more women actually into the engineering field, which is terrific. But they come in and they tell me what they're doing. And I'm the fellow that's got to, if there's choices, I help them make the decision. I was very heavily involved down at the site. There's a 14 megawatt standby power plant down at the World Trade site. And we're actually commissioning it in phases because it's not all ready at once. So we were figuring out how to do that. And my concept is what the Port Authority used on how to test the standby power plant. So relevant every day. Yes.
When you're working with a team of people or part of a bigger company to engineer these sites and everything, how do you handle a situation where you feel like the company isn't making a decision, or like engineering-wise, they're making a decision that isn't in its best interest, and you think that you're said, well, it should be done differently?
Well, you know what? You're bringing out a point where I'm at it. What I'm doing now, my group does building commissioning. So what commissioning is just what it sounds like, testing things. And commissioning is a very dedicated, specific process. So we actually get a chance, if you do commissioning right, you do it, you see the design, and you understand the design. So if something doesn't look right, we could say something there. So it's in our process and in our scope of work to say if something doesn't look right, we could talk about it. We can bring this up. Additionally, we document. I actually brought something with me. It was just representative. It's something that I just grabbed before we left the office. So this is just a test, and you guys don't have to see this, but just to see how involved it is. This is a test for a pump, all right, that gets used along with a big fire pump system. All right, so look at how, here's the pump curves and the performance. I mean, look at how involved some of our testing is. So we ring stuff out 9 ways to Sunday to make sure that it works. And if it doesn't work, it gets logged in, and we solve the problem later. So there's a process for us to do that, and we have a formal way to report what doesn't work and what's not right. So great question. Yes?
I suppose as, engineering is such a rapidly advancing field, and, whatever someone learns, 10 years ago may not be relevant today. You find it's like a natural transition for a lot of engineers to move into upper management, and you know, do you? And also supporting that, you know, for someone who might be more interested in just continuing engineering, also interested in the management side of it, how do they stay relevant?
Great, terrific question, and very relevant. Listen, you know, I hire people all the time, okay? And when I hire folks, I really hope that nothing, frankly, I mean, there are occasions where somebody just didn't work out right, and everybody makes a less than optimal decision on hiring folks. When I hire people, I hope and pray that they stay with me forever, because I also hire people I like to work with. All right? So in order to really have people stay with you, you know, you have to make sure that that your work is interesting. And there are people. There's the technical track and there's the management track. All right. Now, you know, you can't penalize somebody because, you know, from a salary standpoint, because they don't want to be in management. So you have a career track for those teams of people that want to stay very technical. They don't give, or don't care. They don't care about, you know, the financial side of the business. Well, you have to know a little bit about the finance side to stay relevant, but you don't have to know everything. So there's tracks for technical people, and those folks, they take courses, they get advanced certifications, they go on to advanced degrees. I had a young fellow up in Boston, and unfortunately he left the company. He was under somebody else's management, but he left the company after he got his master's degree in fire protection. You know, sad to see him go, but you know, he extended and got his, you know, got much better credentials, and he left. So there's tracks, and for management, you know, you've got to go get a business degree, or show that there's acumen, that you can lead people, that people can relate to you, and that you can, you know, understand the bigger picture. So there's definitely two different tracks. You hit it right on the head, and at some point, all you folks have to make that decision on where you want to be, unless you own your own business, and then you're management and technical and you're everything. You know. So terrific question. Yes.
Personally, do you find it sometimes difficult to stay up to speed with the most recent technology advances?
Oh, absolutely, absolutely. It's challenging. Why? Because you know, my group, we service many different marketplaces. Data centers one, general buildings another. I've done healthcare work. I've done general building work. So I'm spread thin throughout the marketplaces. So yes, it's very difficult. So what you've got to do is read multiple trade and industry publications, go to industry events, join like ASHE's, American Society of Healthcare Engineers, or Data Center Dynamics, or 7x24 Exchange, which is mission critical data center work. You stay up with it and read. So yeah, it's very hard. And also the advances in BIM. Wow, I mean, I did AutoCAD in 1988, and I worked on a CAD machine until roughly 1995. And you know, I loved it, but then I moved to a different track. But you know, keeping up with that field is also difficult. So you're right, and it takes a lot of effort to do so. Yes.
Why did you decide to major in mechanical engineering, going to college instead of other types of engineering?
It was, for me, you guys are gonna laugh, the easiest decision, the most natural decision. I was like, there's something where you kind of feel you were born to do something. So I was always an inquisitive little kid. I remember asking my dad how the transmission worked in the Buick, and he didn't have it. You guys know what a Buick is? Yeah. All right, there we go, because I don't see too many of them around. But I asked my dad how the transmission worked in the Buick, and my dad, who worked over on Madison Avenue in the apparel industry, just shrugged his shoulders and didn't know. Then I remember how I asked him how an engine worked, and I don't know, he had some explanation with a butter knife and how a piston would work. It didn't quite work for me. So you know, I was always a technical kid, and started reading popular science, gee whiz, maybe back in the 7th grade, and probably what made me personally a car nut as a librarian in the 7th grade gave me every old car and driver magazine from 1965 to like 1970. And I think I read them all and understood, you know, what was going on with cars then. So it was a natural decision for me. There was probably nothing else I was going to do. So, and I hope you all feel that same way, that engineering is sort of in, if not engineering, physics or something sciences like chemistry, something in the physical sciences, because that's why you're here. You know, computer-related stuff. You know, there's a whole host of technologies and career paths that didn't exist when I, you know, when I was growing up. Okay, anything else? Great, terrific questions. You guys were terrific. I hope you all wish you a lot of success.